In this video, we'll be looking at two triangles called the special right triangles. And the first one that we'll look at is called the 45, 45, 90 triangle, and it would be very clear in just a moment why it's called that. Alright, so let's look at a square because we will need it to visualize our triangle. And I want us to take our square and cut it at its diagonal. Now remember, a square has corner angles of 90 degrees each. So that is going to be a 90-degree angle. Over here, since our diagonal cut or angle in half, it bisected it, that would mean that this is a 45-degree angle. And over here as well is also 45 degree because it cut that 90 degrees in half. Alright, so now what we are looking at is actually two special right triangles, two 45, 45, 90 triangles. And as you can see, it's called that because that's the size of the angles. Alright, so how does that help us with anything? Well, not so much yet, but we're going to take it one step further here. Now, remember that this originally was a square, and squares have equal sides. So if this is x, then this is also x. And if we go ahead and do Pythagorean theorem, I won't right now in the interest of time, but if we did, we would get that our third side, or hypotenuse, is equal to x times the square root of 2. Alright, this is helpful to know because sometimes we see this triangle and we don't have to do trigonometry, we don't have to do anything crazy in order to figure out a side, an unknown side. All we have to do is just know, oh, you are a very special triangle, so I can tell that the other side length is whatever. I'll show you an example. You'll see what I mean right now. Alright, so let's say we have a triangle, and we know that this is 90 degrees, and we know that this is 45 degrees, and I tell you that this is 7, and I ask you to find everything else. Well, let's start off with the missing angle. If this is 45 and this is 90, we know that this has to complete our 180 degrees. So that would mean that this is also 45, which would mean, oh great, we have a 45, 45, 90 special right triangle, which means that we know that this side has to be equal to this side. Remember from our original drawing that our leg lengths will be the same. Alright, so that means that this is also 7. And according to what we did before, the hypotenuse will be the leg length times root 2. So our hypotenuse will be 7 times root 2. And so we don't have to go through anything with sine, cosine, or tangent if we have a triangle with angles 45, 45, and 90. Let's look at our second special right triangle. Okay, so our second right triangle is the 30, 60, 90 triangle. And from the work that we just did, I'm sure you know that these represent the angles that are in our triangle. Alright, so how does this triangle come about? Most often, if you have an equilateral triangle. So in an equilateral triangle, we know that all side lengths are equal and all angle measures are equal as well. So that would be 60, and that would be 60, and up here will be 60 as well. But I'm going to take my equilateral triangle, and for some reason I'm going to drop the altitude. A common reason to drop the altitude is maybe if you're trying to find the area of a triangle and you need the height or whatever the case. But we're dropping the altitude. By dropping this altitude, what I just did was cut this 60-degree angle into half. So by cutting that 60-degree angle into half, we have a 30-degree angle here. And because it's an altitude, that means it's perpendicular to our base. So that's 90 degrees there. And we have just created, and I will trace it out in red here, we have just created a wonderful 30, 60, 90 triangle. We see the angles, and now we're going to talk about the sides. Alright, so remember that initially this entire thing was an equilateral triangle. Alright, so let's say our shortest side is x. Well, remember that our shortest side was a long side cut in half. So that means the longest, so this whole thing is 2x, which means that this whole thing will also be 2x. So the hypotenuse length of our 30, 60, 90 will be twice the shortest length. Now we can do our hocus pocus little Pythagorean theorem magic. I won't do it to save time, but if we do it, we would find that our third side is x root 3. And that's how the 30, 60, 90 works. So let's look at an example, a simple example, and then I'll take it up one notch to a more challenging example. Okay. That's supposed to be a triangle. That's 30. That's 90. Let's say this is 3. Okay. And so I could now ask you to find everything in this triangle. Well, because we know that this is 90, and this is 30, and the angles have to add up to 180, by default, this has to be 60 degrees. All right. So here we're looking at the shortest side, which is 3. The longest side, or hypotenuse, hopefully you recall, is twice that, which means the longest side in this case is 6. And the medium length side across from our 60 degree, so here is x root 3. So in this case, x is 3, so it's 3 root 3. And that's how you solve for the sides when you have a 30, 60, 90. Much, much easier than doing all the other things if it's not a special right triangle. Okay, so I definitely wanted to show you this example because in this example, you'll have to work with those radicals a little bit more. All right, so we have a triangle here. There are no angles labeled except that 90 degree angle. So how do we know if it's a 30, 60, 90 or a 45, 45, 90? Well, we do know that these side lengths are equal. And because the side lengths are equal, that means that our angles here, our angle measures have to be equal as well. Which means that since that's 90 and we have 90 degrees left to split in half, that has to be a 45, 45, 90 triangle. But that's not what the question's asking. It does help us to get to where we need to get to though. So, in our 45, 45, 90 triangle, hopefully you recall, if that is x and that is x root 2. So 12 is x root 2. X root 2 equals 12. All right, so now we can figure out what x is based on that. And hopefully you remember this from algebra. If not, I'll try to be very clear. So x root 2 is equal to 12. So we are trying to isolate our x, and in order to do that, we have to divide both sides by root 2. All right, when we divide both sides by root 2, that goes from that side, and we get that x is 12 over root 2. Now, unfortunately, we can't stop there. It would be wonderful if we could, but we're not supposed to have radicals in our denominator. We're not supposed to have any square root signs in our denominator. In order to get rid of that square root sign, we have to do the opposite of square rooting, which is squaring. So we're going to go ahead and multiply the bottom by the square root of 2. But we can't just do that to the bottom and nothing to the top. We have to do the same thing to the top. So what we multiply by the bottom, we multiply by the top as well. And we get that x is equal to 12 times root 2 over root 2 times root 2. All right, cool. Well, 12 root 2, I just rewrote the top, over square root of 2 times 2, which is 4. We actually know what the square root of 4 is. The square root of 4 is simply just 2. So it's 12 root 2 over 2. And now we have two things here, numerator and denominator, that actually have a common factor. Our common factor is 2, goes into itself once, and goes into 12 6 times, which means that our value of x is equal to 6 root 2. And that's it.